Hello, everyone. If you are ready, we can start. My name is Martin. I am an Odoo developer, and today I will make a presentation about how to develop an app with the Odoo Framework. As you know, Odoo is a suite of business apps, but it is also a nice framework to develop your own application depending on your needs. And I will try to tell you today how to quickly, after this 50 minutes presentation, how to already set up an app up and running. Okay. So let me show. Like this. If you are in a hurry and want to go to watch another presentation, this is the slide you have to remember. We have documentation put online. At the moment, it's still the 10.0 documentation, but in a few days, we will publish the 11 documentation. I can show you here what it looks like. And there you can find all the resources needed to explain more in detail everything I will talk about today. You have there the API, all the API commands, all the field definition, the views. If there is something that is not clear, you will probably find the answer over there. You can also get the content, these slides, and I will also show you some codes during this presentation. Everything is put there on GitHub. Okay, Odoo is working with a 3-tier client-server database. We are on a one app page that you access through a browser that is in a web client that is fully written in JavaScript. But today I will not talk about this the JavaScript part. There is other talk about that. What's more interesting for me, it's to talk about the server that is written in Python. All the logic and database model are described in Python, and we are using a PostgreSQL database. Since this version, we are using Python 3.5, while we were using Python 2.7 until the previous version. For this presentation, I will give a small example that is totally without any links to the existing Odoo apps. This way, we will have a standalone module. In this case, the module will be a plant nursery shop where you can buy some plants. We will create a few models to describe a list of plants, some customers, some very basic orders for customer to buy plants. And this way we will learn how to make what is the structure of a module, the definition of the data, to make some logic, some very simple views and actions. And hopefully we will cover that everything in 50 minutes, so we already have a good basis to start your own application depending on your needs. An Odoo module is composed of a manifest file. This is where we will describe, we'll give all the description of the module. I will show you just after that. We have the Python code that contains all the models and the logic. We have some data files. Data files are usually written in XML, but you can also use some CSV. And we have some front-end resources like JavaScript, CSS, some images. I will not talk about this part today, but in the following presentation, Thibaut and Martin will talk a bit more about the JavaScript part. Okay, here you have the manifest of a simple plant module. So the manifest is is a file inside your module folder that is called __manifest__.py. And it's composed of a dictionary with a few important keys. You have, for instance, the name, that's the name of the module, version, all these are quite self-explanatory. The category, if you have multiple modules with the same category, it will be rendered the same way, it will be grouped together on Odoo. You have a summary explaining shortly what your module does. And here, the nice part, for instance, you have the depends key. The depends is actually a list of modules that are needed to have your module up and running. So let's say my module will add some features to the accounting module. I will put here account. It means that when I want to use my module, I need to have the account module already installed. Also, if I don't have the account module, when I install my module, it will install that module. If I want to remove the account module, my module can no longer work, so it will uninstall also my module. This is the kind of dependency that we express here in the manifest. If I want to add some mail feature, I will depend from the mail module. Here in my example, I have a standalone application, so I will only put web. Web is always present on an Odoo instance. This is the simple web interface module. And then we have the data tags. Data is the list of local files that will be loaded when I install or I upgrade my module. For instance, here I gave some example with a CSV file and then my data to have to populate the database, some views definition. All these are files that I will give you some examples later. We have also the demo tag. This is not mandatory. It's when you create a database, you can always choose to launch it in the production mode or in the demo mode. And in the demo mode, it will read some additional files that you can define here. This way, when you want to present what your application does, you can already have some predefined data for the sake of the example. Some CSS, some flags like installable, if you can put it to false if your module is not ready for production yet. And finally, you have the auto-install flag. This is a nice feature that allows you to have your module to be automatically installed when you have all the dependencies that are given over there that are installed on your server. This means that if I have a module that will make a bridge between the sale and the warehouse management, for instance, I can put sale and stock modules in my depends and auto-install equal true. This way, it will automatically be installed as soon as all the requirements are met, and it does not require the administrator to manually install my module. It can automatically add some features. I can show you here. I will show you the commits at the same time. So here I have my basic module that I have made. Sorry. You just also need to create one init.py file. This means to be able to import it for the Python framework. So if you are used to developing Python, this should be familiar to you. Okay, So now let's go to the models definition. Here we have, with the manifest, we have created our module. We can install it, but it obviously still does nothing. Now we would like to express some fields to describe some models that will be converted into PostgreSQL tables and columns. So in Odoo, it's quite easy to create some new models and fields. You just create some new Python class. The names of the class here, plants and customer, do not really matter. What actually matters is the underscore name tag over there. This is the technical name of your model. Every time you will want to make a reference to this model, you will use this tag. This is also what will be used to create your PostgreSQL database table. So your model will be called, your PostgreSQL table will be called nursery underscore plant, for instance. To gain all the features from the ORM, you always need to create a Python class extending models.model. Import it here. And then you can create your fields. The fields declaration is quite easy. Name equals fields.char, price equals fields.float. All these to create here. I create a model called nursery.plant that has two attributes, a name and a price. The name is char and the price is a float. Here I give you the link in the documentation to the field. We have many types of basic fields. I can show you. So we have the char fields, Boolean, integer, float, text, selection, HTML, date. All these are the simple data model that you may want to use for your logic. As you see, we can also specify some attributes. So, for instance, here the first attribute is the label of my field that will be used when I will render the field in my application. And we can also add some non-mandatory field like required equal true. This will be converted by Odoo as a not null constraint in the PostgreSQL database directly. It will also make the web client behave differently, like you cannot create a record without filling out this information. I will give more examples of attributes here. The help is just the tooltip when you put your mouse on the field and it's you will show a pop-up to help your user what are the information that you will want to put there. Okay, so with this model definition, when I install or upgrade my module, it will have directly the effect on the PostgreSQL database and create the tables, create the columns, add the SQL constraint, everything. But you still see nothing in the interface. Hopefully, it's quite easy. We just need to add some data. So if I go back to my code, so here in the second commit, I created the models that I show you. It's more or less the same. Just as a reminder, don't forget to import. If you put it in different files, don't forget to import it, obviously. And then you can create some data file. Here, I create a new file that I called action.xml that I need to put inside my manifest to say, okay, when you install or upgrade, load this file. And it will contain, and this is just a snapshot. And inside this data file, I will have inside some Odoo XML tags the following information. First, we define two menus. The menus are in my application. This is a menu, and over there, these are the other menus. So, quite easy to understand. I define my first menu with the tag menu item. I gave it a label and an ID. The ID is a string that you can choose. It must be unique inside your Odoo module. And every time you want to make a reference to the record you have created in your data file, you will need to use this data ID. For instance, here I create my root menu, and then I create a second menu, and I specify that my second menu is the child of this nursery root menu. This way, I make a direct reference, and this is how Odoo will see that inside this plant nursery module, I have my other three menu. And then I can specify an action. And here I create an action record. So when you will create some data inside your Odoo application, you will always use the following form. You will create a record tag with inside some fields. Here, this is the example with the actions. The action will use the model here action act window. This is just some chosen name that you have to remember for it to work. But in this is actually the model that's defining some actions. In my previous slide, I created a model that was called nursery.plant and nursery.customer. Here the action it's here action act window. So if you want to create some plant data, you will create a record models equal nursery.plant, for instance. Again, you give it an ID, and then you need to give it like the target model. This is like the minimum information to say, okay, when I click on this menu items, I execute this action that will list the nursery.plant records. Concretely, this is this menu that will give me the list of plants record. If you try the code that I have been given, you will see this. Odoo will automatically generate some basic views for the. Here you have the list view, but you can have also some automatic form view that will put all the fields that you have defined in a random order. It's not very pretty, but it does the job. And with a few lines of code, we already have some simple modules. I will not go much into the details of advanced view, but you can also define some more complex views. Here, I gave you an example of the way to define the form view, where I can put my name inside H1, then I create a notebook with all my fields. This will give me, for instance, the following result. I have added more fields that I will show during this presentation, but so you get the ideas that we can go way more into details about with the complexity of the views. There is a lot of different possibilities. For that, I advise you to check the existing views, and also, again, the documentation gives a lot of explanation about all the different attributes. But the subject of the advanced view is can already take hours of another presentation, so I will just skip to the next part. So here I show you how we could make some basic models with some descriptions, but they had no interaction between each other. Now, in Odoo, we can also add some relation. This is done through these three types of fields: the many-to-one, one-to-many, and many-to-many. The many-to-one is the classic foreign key in PostgreSQL. It's a relation to another module, to another model. And the one-to-many is the inverse relation. So, for instance, later in the example, I will give I will create an nursery order model where a customer can buy a plant. So on my order, I will add a many-to-one field towards a plant. From one order, I buy a plant. And then from the plant, I can get the list of orders that I have made. The order to the plant is the many-to-one, and the plant to the orders is the one-to-many. This is the inverse relation. The many-to-one is the foreign key, while the one-to-many is a virtual relation that is computed based on all these modules. And then we have also the many-to-many. This is if you need to make some a join table when you have two different models. So again, defining the relation between models is quite easy. You just create some new fields. Here, on my example, on my model nursery order, I add a field of type many-to-one, and then I specify the target model. Here, I create a relation from the order to the plant. And this relation is mandatory. On the other model, on the plant, I define the inverse relation. I create the one-to-many fields, that is from the nursery plant to the nursery order, and I specify which field contains the relation. So in this case, plant ID over there. This gives me the following result. When I create a new order, I can specify a plant over there. I access the list of existing plants, and from a plant, I can access the list of existing orders that are in the inverse relation. So here, to get what I just showed you, I added some new menus to access orders. I access the list of orders inside my view, but the most important part is here. I define my order, nursery order model with two relations, one towards plant, one towards customer, and the inverse relation over there. Okay, so here with this, you can go a bit further. You could create your models and have some links between each others, but there is still no business logic here. It's still plain data and just fill up some information. Now, in Odoo, we have already some nice ORM feature, where the four most common methods are the following: read, write, create, and link, that will be called each time you want to access a record, modify a record, create a new one, or delete one. These are the methods that are present on every model that inherits from our models.model Python class that I showed in the model definition. what we will want to do is to modify the behavior of these basic methods to add some more business logic. Here, I gave an example where we modify the behavior of the write method when you modify a record, and the unlink when you try to delete it. So in these examples, I say, okay, let's modify the write method to add the values, to add the modification date inside the field. So when I access the write method, I have an attribute values that contain. This is a dictionary that contains all the values that are modified through the interface. So if I try to modify here, I will send a write call with the field name containing my new value. And inside this value, I set a value to my field last modification. So obviously you need to create a new field called last modification that will be set with no. And then I call the Python super method to be able to still use all the existing ORM methods to apply all these changes to the database and everything. So here in my example, I added the last modification, that is a datetime field. And there every time I modify it, I update a last modification field. And this, so I can show you. I've already the last modification. If I change the customer, this date is updated to no. And then here you have the unlink. So the particular of this here is that you see that I make a loop. This is because when I call an ORM method, I can execute it on one or multiple records. So if I try to delete a record, I can either try to delete one, but I can also try to delete multiple of them. So in my example here, self can contain one or the multiple records. So for this reason, I need, every time I am accessing the content of a record, I need to iterate on it. So maybe self contains only one, but maybe contains 2, 3, 4 records. So here, for order in self, I access the value of my field state. And this is done very easily with order.state. If I want to access the name, order.name, order.last modification, I check. If it is confirmed, then I raise an error. You cannot delete confirm order. If not, I delete my record. So here I have my orders. Here I have a confirmed order. If I try to delete it, you cannot delete. I get the error. Okay, so now it's getting interesting. We can already have some basic interactions, apply some, modify some fields on the fly and things like this, but it's still a bit heavy for some complex values. Let's say on an invoice, you would like to display the total of your invoice. You could overwrite the right method, but it's getting easily a bit messy, and we can do that more easily. And here we can do all that with the computed field. The computed fields are some fields where the value will be computed through a specified Python method. This allows me to have some more business logic, like I said, the total of an invoice with or without taxes and things like this. I can store it or not in the database. I can store it to access it faster, but it will also mean that when it's updated, it will be slower. So it's always, you have to choose, it's a bit of a trade-off depending on your use case. Will I modify it on multiple records very often, or will I access it quite a lot? So you can store it or not in the database. Okay, to define it, again, this is quite easy. In this example, I added on my nursery plant model a new field called order count that will just be the number of orders that have been made for my plant. And the definition, so again, a simple fields.integer, as it will contain an integer value. And then I can specify the methods that will be called when I want to compute the value. Here, I created methods called getTotalSold. I will store it in the database, and I will give it a label that is total sold. And then, to compute it, again, I make a loop because maybe I am accessing this value for more than one record, for plant itself. And I assign a value, plant.orderCount equal the number of orders that are displayed on, that are present on my previously defined order IDs field. One very nice and important attribute is over here the decorator API.depends. This contains one or multiple field names, and is actually the depends, the trigger that specify which fields are needed to compute my value. In this case, I specify order IDs because my order count field is computed based on the order IDs field. This means that as long as the content of the field order IDs does not change, my method will not be retriggered. It will keep the value. But as soon as I remove or add another record in this, the method will be called to invalidate the previous value and recompute it. So when I say that you have to think about a trade-off between access and update speed, it will also depend here on the depends. If my depends is multiple fields that are modified all the time, it means that my value will always be invalidated and recomputed all the time. The performance will not be good. So here I can show you I added my field, defined the methods. Don't forget to import the API for the decorator. And I just add it in my views. This. Here, total sold orders. I create a new order for the sunflower. And I see that the number went from 1 to 2. So this example is quite easy, but this is where all the complex, you can go very deep in the complexity of the computation. This is how you will handle multi-currency amounts, or I give the example with an amount with or without taxes. This kind of things is done with here. In the documentation, we explain here the computed fields, and you can have also some different methods that I will not talk a lot, where you can, here I gave the compute. This is when you read the value, but you can also set an inverse method when you want, okay, if I write 50 as my order count, it will create my 50 orders, for instance. So when I set a value, that's the implication it will have, or the method that will be called when you search. So again, we can go very far in the complexity. Okay, last but not least, in my previous example with the ORM interaction, that was over here, I gave a way to raise an error if you try to delete a record. You could do the same, let's say, to prevent the modification of the plant if the state was already confirmed, or things like this. You can do that with the by extending the write method, but in Odoo we also have some built-in constraint mechanism to be able to do that. When you define a constraint, it will be a Python method that will be executed each time you create or modify a record, and it will make your code a bit more readable than overriding the create and write each time. So here you have an example. I define a constraint. I add a field that is called number in stock. That's a basic integer field that I like here. And I want to raise an error as soon as I have more orders than the number in stock that I just created. So here I create my number in stock field, and then I create my method, and I decorate it with, this time, not an API.depends, but API.constraint that is using the same syntax as for the computed field. It's the list of fields that as soon as you modify one of these fields, you will execute the method to check the integrity of your data and make sure that you do not violate the constraint. So here, as soon as I modify either order count or number in stock, I call my method and make sure that order count is equal or lower than the number in stock. If not, I raise an error. Okay, so this ends my presentation of the Odoo Framework. This hope gives you a rough idea on how to use it, what are the capabilities. This is only scratching the surface of what is possible, but now I hope that you will understand what you see when you use Odoo and how to go into the code of the existing module to understand it and to be able to navigate into the documentation that I show you and hopefully make your own business apps. in my presentation, I show you the basic of the models, but in the following presentation, Thibaut will show you how to, based on this same example of plant nursery shop, how to go further by creating some controllers to have some nice front-end page and have a bit of interaction with JavaScript. So, thank you, and if you have some questions.